today onwards I will start a very important lecture series which is called linear algebra. So linear algebra having so much application in every field. Not application wise, if you are writing any competition, then also it's very important part of your syllabus. So first topic which is very important for linear algebra, that is called vector space. So what is vector space and what are their properties, what is subspace, linearly dependent, independent and other properties, everything I am going to explain in this series. So please stay with me and hopefully you enjoy and you will understand easily. So now I am going to start vector space. So vector space, what is the definition? Its definition means a system V plus dot is called vector space over field F plus dot if it satisfies following condition. So remember, for vector space, two things required. One is V. V is called set of vectors. Means we have a set which contains vectors and two operations, plus and dot. Plus is called internal operation and dot is called external multiplication. So what is that? I will explain later. And field, we require a field. Field means a system which is having multiplicative inverse. If you want to know field, I will explain later. But field here you take as if scalars, set of scalars, from where scalars comes. Suppose we have a vector 3a. 3a vector means 3a1, 3a2, 3a3. So 3 is known as scalar. So 3 comes from field. Field means set of scalars. Means from where scalars will come in picture. And V is set of vectors. So it satisfies following conditions. Means following properties. What is first property? First property is x plus y is equal to y plus x. Wait, I will explain addition where plus is an operation from V cross V to V such that A, when plus applies on A comma B, it will give A plus B. This is called internal because A and B both are element of V. So resultant when plus applied on A comma B, what is the value? A plus B. Because A and B belongs to V, so A plus B also belongs to V. Because math defined, that's why it belongs to V only. So if A and V belongs to V, so addition of these two also belongs to V. This is called internal binary operation. Internal binary operation. And dot is from F cross V to V such that when dot applies on A comma B, what is the value? A dot B. Alpha of equal to alpha dot A. This is called external binary operation. Alpha comes from field and A comes from V. When dot applies on alpha comma A, the value is alpha dot A. It's the same like 3 multiplies a vector. A scalar with vector. When you multiply, what is the resultant? Vector. So same type. This is called external binary operation, and this is called internal binary operation. In short, it's very simple. Don't come in detail. If you are from engineering background, plus and dot. Plus is called internal operation because if two vector you take, you add, nothing outside things required, so resultant also vector only. And dot is called external multiplication because alpha comes from field. Here alpha from field and A belongs to vector. So we come to the definition. V with addition and external multiplication is called vector space over field F if satisfies following condition. For vectors plus and dot, what is the first? X plus y is equal to y plus x. This is called what? Commutative law. Second, associative law. It means either you add first two vectors and then z, or x plus y plus z, always satisfied. Associative. Third is, there exists 0 belongs to V such that a plus 0 or x plus 0 is equal to x for every x belongs to V. Here 0 is called additive identity. And fourth, for every x belongs to V, there exists minus x belongs to V such that x plus minus x, what is the value? 0. Minus x is called additive inverse of x. So these four property already you go through in your class 9th. First is called commutative law. Commutative law and associative law always satisfies because for addition, because it's an operational property. So plus always satisfies addition, commutative property and associative property, because this property based on operation and addition always satisfies. Third one is called inverse identity. For that, 0 must belong to V. There it is 0, such that x plus 0 is what? X only. Then 0 is called additive identity, and 0 must be required in V. And fourth one, whatever x you take in V, there exists minus x, such that x plus minus x becomes additive identity. So these four properties required for internal binary operation to make it vector space. If these four properties satisfy, we go for external binary operation, which is scalar multiplication. Means what is fifth one? Fifth one, for alpha of x plus y is equal to alpha x plus alpha y. You know this one. This is distributive law for scalar. This is called distributive law. And sixth one is again distributive law for multiplication. Alpha plus beta x is equal to alpha x plus beta x, where alpha beta belongs to field and x belongs to v. Seventh one is 1 dot x is equal to x, where 1 belongs to field and x belongs to v. 1 must belongs to field. And 8, alpha of beta x is equal to alpha beta of x, where alpha beta belongs to field, x belongs to field. So these 8 properties, 4 for internal binary operation and 4 for scalar multiplication. If v with plus and dot satisfies these 8 property, 4 for plus, 4 for dot, then v plus dot is called vector space. So again, v plus dot is vector space over field f. Here f required, here operation plus dot is little same or bit difference is here, but almost same addition and multiplication. So for here dot means multiplication between scalars, and here dot means external scalar multiplication. So that is all difference. Addition is same line. So if v plus dot satisfies this property, 4 for addition and 4 for dot, then it is called vector space. Remember here in between alpha and beta, here alpha beta both belongs to field. So which operation is there in between? Dot of field. Now alpha beta is scalar, x is vector. So in between what is the operation? Vector multiplication. External dot. So same like one is field, x from vector. So in between what is the operation? Vector only. So same type you do. Now we are going to do some example. I'm not going to prove every example. I will do one example. But the remaining thing you can do by yourself. If any problem is there, you can put the message in chat box and I will try to resolve that issue. So first example which comes in mind, Rn over R is a vector space. Here V over F, it means V is a vector space over field F. So Rn forms a vector space over R, means R is a field from where scalar comes and Rn is a vector with respect to operation. How operation defined? How plus defined? Take any two elements x1 y1 or x1 x2 xn plus y1 y2 yn. How it is defined? What is the value? x1 plus y1 comma x2 plus y2 dot xn plus yn. And how multiplication defined? Alpha of x1 x2 xn is equal to alpha x1 alpha x2 alpha xn. So this is the operations defined. Addition between two vectors, because we have taken Rn, so Rn contains how many tuples? N tuples will be there, na? x1 x2 up to xn, that type element whose having n coordinate. This is also elements of Rn. When we add, how adding will perform? Just coordinate wise addition like vectors, I with I, j with j, k with k. This is scalar multiplication. Alpha comes from R and x1 x2 xn is a vector. When scalar multiply with vector, how you do it? It multiply with all coordinates. So this type operations are there. And now it forms a vector space. How we solve? See, already I told first one, x plus y is equal to y plus x. It is obvious because this is addition, and addition always satisfies commutative law and associative law. This is called inherent operational property. Means it's depend on operation only. So it means it will always satisfy. No need to prove anywhere. Addition always satisfies commutative law as well as associative law. But if you want to prove, you can prove it. It's very simple. X means this one, y means this one. Two elements. Take two elements. What is x plus y? This one. This x1 plus y1 belongs to where? R, real number. Real number always satisfies commutative property. So x1 plus y1, if we can write y1 plus x1, y2 plus x2, yn plus xn, then separate. This is y plus. Similarly, you can do associative law. So that's very easy. Now third property. What is third one? That is 0. Yes. That is 0, 0, 0, 0. How many times? N times. N times 0 belongs to Rn such that x1, x2, xn plus 0, 0, 0, 0, 0, 0 n times. What is the value? x1, x2, xn only. So this is called IID. Now for inverse, 4. For every x1, x2, xn belongs to V, there exists minus x1, minus x2, minus xn belongs to V such that what is the value? 0, 0, 0. When you add, what is the value? 0. So it means inverse also. For every x1, x2, xn, there exists minus x1, minus x2, minus xn. Because if x1 belongs to R, then minus x1 also belongs to R. x2 belongs to R, then minus x2 belongs to R. So definitely for every x1, x2, xn, there exists this one. Such that this. So this is for internal binary operation. Now we are going to for scalar multiplication. What is the first one? What is fifth property? Fifth property is alpha of x plus y is equal to alpha x plus alpha y. And this is called distributive law and it's always satisfied. You can prove it easily. How? Take x1, x2, xn plus y1, y2, yn. When you add these two, what will come? This one. Now take alpha outside. So how scalar multiplication defined? You know alpha comes inside. So alpha xn plus alpha y1, alpha x2 plus alpha y2, alpha xn plus alpha y1. Again separate, you will get the same value. So easily you can do. Sixth is alpha plus beta of x is alpha x plus beta x. This one also you can do easily because alpha plus beta this time you have taken in the scalar. So what is x? x1, x2, xn. When alpha plus beta multiply here, what is the resultant? Alpha plus beta will multiply in each coordinate. So easily you can separate them. Means calculate left hand side value and right hand side value. And both always equal. What is 7? 1 dot x is equal to x. So yes, where 1 belongs to field. 1 belongs to field? Yes, here field is what? Real number. And in real number 1 is there. So 1 belongs to f. It's automatically satisfied. And what is 5th? It's alpha of beta x. This is also obvious. What is beta x? If you want to prove, I'm going to prove this one. See, beta x. So beta x1, x2, xn. of alpha. What is the value? LHS. Beta x1, beta x2, and this is beta x1. Now take alpha inside. Alpha beta of x1, alpha beta of x2, alpha beta of x1. Now alpha beta you can take outside. Over. This is your 8th property. So in this way we can tell Rn forms a vector space over R. Now I will write some important. Example which you can prove by yourself. Set of all polynomial forms a vector space over a polynomial addition, how we do and how we do scalar multiplication. Correct? Means if fx and gx belongs to V, then fx f plus g of x, how defined? Fx plus gx, where fx and gx are two polynomial. In other way, I will tell it polynomial type. Suppose we have polynomial ax, a0, a1x, anx to the power n, and bx is b0, then how we add ax plus bx? We know very well. Polynomial addition. And second, scalar multiplication alpha of is alpha a naught, alpha a x to the power. With these two operations, a set of polynomial always satisfies all 8 properties. That's why it's called forms vector space. Definitely here degree must be same. Set of all polynomials of degree up to and whatever degree they will have. But it forms a vector space. Third, set of all continuous functions defined in closed interval AB. CAB means set of all continuous function defined on closed interval AB forms a vector space with respect to addition of two continuous functions, means fx plus gx, how we add, and scalar multiplication. Both fx plus gx, f plus g of x is what? Fx plus gx, and second alpha f of x is alpha of fx. With these two operations it forms vector space. Third, Mn, set of all matrices of order n cross n forms a vector space with respect to addition of matrix and scalar multiplication of matrix. Okay, so these are the example which forms vector space. So try to do it by yourself. If again any problem is there, you feel free to ask me. In next lecture, I will explain about a different concept which is called subspace. That's very important, and definitely question will be there.